Assalamualaikum and good morning everyone. Okay, now we continue with the second part of the week 12 video, which is now we'll focus on finding solution of non-homogeneous second order ODE. So in the previous part 1 slide, with part 1 video, we focus on how to find solution for homogeneous. Okay, now we look into the non-homogeneous type of equation. This is a bit challenging than the homogeneous. Homogeneous is a bit straightforward when the all equation is equivalent to 0. Okay, all right. If you recall from the homogeneous solution, for the homogeneous solution, we will have this equation all is equivalent to 0. Okay, so we have discussed that. Now we will continue with the non-homogeneous problem where the answer for this equation are not equal to 0. Okay, if the right hand side component Rs are in the simple form of exponential, polynomial, sine, and cosine function, we can use method of undetermined coefficient. Okay, so again, let me rephrase again. If the Rx is in the function of exponential, and then all the function of polynomial or sine or cosine, we can use undetermined coefficient. Okay, so the Rx here. So look at the later, you will look at the differential equation and look at the answer. Either it is one of these four. So we can use method of undetermined coefficient where the right hand side, which is the Rx here, is equivalent to e to the power of alpha x, Pn x. Okay, so we can obtain the differential equation like this, where Pn is the polynomial function with the degree of n. Okay, so we can propose a possible particular solution of Yp equivalent to E lambda x Qn x. Okay, so the solution for non-homogeneous linear differential equation is given by YC, the complementary solution, like what we did in homogeneous solution, plus YP, particular solution from non-homogeneous part. Okay, so we will look into this in the next few slides. Alright, so this is general procedure for the method of undetermined coefficient, given that the ordinary differential equation of non-homogeneous is given as this: a d power of 2y dx power of 2 plus b dy plus cy equivalent to rx. Okay, first of all, what we need to do is we solve the homogeneous part first. I mean, we find the yc first. Okay, so in order for us to find the solution for yc, this part, this equation, we make it equivalent to 0, and then we find yc. Okay, and then after that, then only we find particular solution. We solve the non-homogeneous part, which is yp. Okay, so yp is given as possible particular solution as exponential to the power of alpha x Qn x. Okay, and is the degree of the polynomial. So check, and then after that, we check whether yp and yc are linearly dependent or not. If they are linear dependent, you have to give treatment or cure to yp to obtain linearly independent solution, and then propose particular solution after cure, either using this one or this one. We will look into this later in the example. Step number 4, we need to solve the undetermined coefficient of the particular solution by comparing the coefficient on both sides of the equation, and then write the total solution as yc plus yp. This is the homogeneous part, and this is the non-homogeneous part. Alright, so in summary, we need to always solve the complementary solution first, meaning we need to find yc first for homogeneous part, before we propose the particular solution. Okay, before we propose the answer for yp. Okay, so the method of undetermined coefficient is only applicable to second order non-homogeneous linear differential equation where the right hand side component Rx are restricted for exponential, polynomial, sine and cosine. The exponential function is related directly to the e to the power of alpha x, and the polynomial function is directly related to p and x. Okay, so the exponential function e to the power of alpha x is related indirectly to cosine and sine using Euler's formula. This is Euler's formula. Euler's formula said that if we have exponential function to the power of plus minus conjugate ix, this is similar. This is similar as cos x plus minus I sin x. Okay, this is a Euler's formula. Okay, so this is example of Euler's formula. You know that the formula for Euler's is given as this. So if we have e to the power of negative I tan x, meaning that this tan x can be transformed into cos tan x minus I sin tan x. Okay, so this is the imaginary part and this is the real part. Okay, so we can represent the answer in terms of imaginary part like this. Where we say the imaginary part of this equation, meaning that is negative sine tan x lah. So if we say that this is a real part, we want real part only for this equation. So this is equivalent to cos tan x. So again, let's say the question asks what is the imaginary and real part of EI 5x. So EI 5x here is equivalent to cos 5x plus minus I sin 5x. Okay, so this is the real part and this is sin 5x is the imaginary part. Okay, so make sure you know how to differentiate between real and imaginary, because later on we will see the solution that requires us to only present the answer in terms of real or in terms of imaginary part only. Okay. Alright, so this is the table of possible particular solution proposed for the second order non-homogeneous ODE. Again, this table you can refer to. You don't need to memorize, because it has a lot. We have just now what I mentioned is if our x is exponential, polynomial, or sine and cosine function. Okay, so we have a few set of possible particular solution. You don't need to memorize, but again you can always refer to this table, or in your notes the table is in the page 111 to 112. It's the same thing. I just summarize it in the table. Okay, if the Rx here, the right hand side here, this is the way of looking at it. If the Rx is the function of exponential function, let's say e to the power of negative 3x. So the particular solution will look something like this. Okay, if the Rx is in the sine function like this, sine 5x, sine x, sine 3x, okay, so the actual particular solution is actually imaginary part of this, imaginary part of particular solution. If the Rx is pure cosine function like this, cos 6x, cos x, cos 2x, okay, is actually the real part of the particular solution. If the solution is a mixture of exponential and also cosine like this, you may find the solution is like this. Sorry, the Rx is like this. So the answer is given, particular solution is given as this. A e to the power of the alpha x here is given as 6i minus 3, depending on the value of n and also the value of alpha here. We will look into it later with the example. And the actual answer is the real part of the yp. Alright, if it's pure polynomial, Rx is pure polynomial like this, 6x power of 3 plus px power of 2 plus 5. The particular solution is given as this, the polynomial also. If it's mixture of polynomial and exponential function, by multiplication, for example like this, by multiplication, so the answer will look something like this. And if it's mixture of polynomial plus exponential function, this one is multiplication, this one is by addition, the middle part is by addition. So you can solve separately, one the polynomial part and the second one is the exponential part, and combine particular solution of polynomial and also exponential like this. It can be solved separately and combine the result later. Okay, after this we will look into one by one on each type of possible Rx, and then we will look into possible particular solution for each type. Alright, so the next step is we want to check whether YP and YC, the particular and complementary solution, are linearly dependent or not. So solution to the non-homogeneous is actually the combination of both YC and YP. Okay, so there are three cases solution. If case 1 is alpha is not equivalent to M1 and M2. So if this situation happen, YP and YC are linearly independent. Okay, if alpha is equivalent to M1 or M2, but M1 and M2 are not similar, we need to propose other form of YP. If alpha is equivalent to M1 and M2, we also need to propose another form of FYP, of YP. Okay. Alright, so this is for the case 1, case 2 and case 3 that I mentioned just now. Case 1 is okay lah, this is what we want, meaning that the alpha is not equivalent to M1 and M2. Okay, so the solution can be possible complementary solution can be either these three lah, depends on the value of b power of 2 minus 4ac, that what we did in the previous video. So proposed particular solution for non-homogeneous part is given as E alpha x, Q and X. Okay, if alpha is not similar as M1 and M2, they have no constant. We can directly apply the particular solution as shown in this format. Because YP here has various form of SYC, they are linearly independent. So this is the solution that we want actually. But we also will encounter that the value of alpha is similar as M1 or M2, but M1 and M2 are not similar. Alright, so the solution can be in term of this form for YC. This is where for AC you get negative value ni, this is where you get positive value. Alright, so the solution can be either in this format. So the proposed particular solution is given as this. Okay, we can't use solution like this because this one has the similar form SYC and can cause zero right hand side function. Okay, there are cases also when the alpha is equivalent to M1 and M2. So this is a particular solution, complementary solution for YC, and this is the particular solution form for YP. Okay, so we cannot use this one or this one because this form have the similar form as YC and will cause right hand side function will be 0. Okay, alright, let's look at the example here on how to solve this equation. So this is non-homogeneous equation, right? This is non-homogeneous because this part, the right hand side part, is not equivalent to 0. And look at this, the right hand side here is in the exponential function. So refer back to the table that we did just now. So if it's pure, now the right hand side is pure exponential function. Okay, so the possible particular solution is in the form of YP is equivalent to E alpha X, Q and x. Okay, so first of all, what we need to do when we get this type of question. Alright, so the first thing first, what we need to do, we need to solve for a complementary solution first, with the homogeneous part first. We need to find what is yc, yeah, okay. So from here, I transform it into m power of 2 minus 3m plus 2 equivalent to 0. Okay, so from here is if I taking b to b power of 2 minus 4ac, I will get b power of 2 negative 3 power of 2 minus 4 minus plus multiplication with 1 and also 2, I will get 9 minus 8 here, so I will get the value of 1. So this is b power of 2 bigger than 0. Okay, so to solve this, I can factorize it into m to power minus 2, m minus 1 equivalent to 0, where m 1 is equivalent to 2 and m2 is equivalent to 1. Alright, so therefore the complementary solution is given as C1E m1x plus C2E m2x, right? Alright, so here C1E 2x plus C2E m2 is x, right? So leave it as this. Alright, so this is our YC, our first step. Okay, second step now. Okay, let's do the non-homogeneous part. Okay, before we do non-homogeneous part, we need to find what is the value of alpha, because our particular solution here will be in this format, and what's the value of alpha and what's the value of n here. All right, okay, so the right hand side here is actually in the form of E alpha x P and x, right? And is the n depend on the polynomial degree. So from here, E alpha x, E1x lah. So alpha is equivalent to 1, and there's no polynomial on this side. So n is equivalent to 0. So from here, we know that later on, our final solution will be in this form, e to the power of alpha x, which is 1, 1x q naught x. So this is equivalent to a e x lah. This one refer to the table just now. If it's full exponential, the solution will be in this format. It will be in this format actually, alpha x. Right, so refer back to the table like just now. Okay, how from here to get here. This is referring to the table. Refer previous table. Okay. Alright, so since alpha is equivalent to 1, alpha is equivalent to 1, this is also similar with the value of m1 here. M1 pula, m2, sorry. Right, our m2 is equivalent to 1. So treatment is necessary because alpha now is similar to m, to either one of the m. So treatment is necessary. We identify that first. Treatment is necessary, and then referring to the slide number 9 just now. So if alpha is equivalent to one of the m, but m1 and m2 are not similar, so the solution will be in the form of alpha x, q, and x here. So for this case, yp later on will be x a times a e to the power of x. Alright, I continue the calculation in the next page. Alright, so after making yp is equivalent, we give treatment to the yp just now, equivalent to ax e to the power of x here, meaning that Now we already make it as linearly independent. Okay. Alright, so now let's solve for let's solve the coefficient of A here. Coefficient of A here uh, for the proposed particular solution. So let's find dyp dx. So we differentiate this in terms of x. Okay, so this is uv. There are two parameters here, x and also ex. So after you differentiate, you will get uv prime v prime uv prime, you will get back ex plus v v u prime you will get the value of 1. So here you will get ax ex plus a e to the power of x. Right, then we take the second order of derivative, the x power of 2. So you will get a x ex plus a ex, and then this one you will get aex also. Okay, this part solve like this and then plus aex. So 1 1, so got 2. So ax ex plus 2aex. Okay, so now we insert back on the uh, equation in the question just now. The equation states that the y power of 2 dx minus 3 dy dx plus 2y equivalent to ex, right? So let's put it back. D power of 2 here, ax e to the power of x plus 2aex minus 3 times ax e to the power of x plus aex plus 2y. Y is ax e to the power of x equivalent to e to the power of x. Okay, so let's solve this one. 1ax ex, this one is minus negative 3ax ex, so you get 2ax ex, sorry, 1, this is 1, this one minus negative 3 plus 2, so become 0 lah. Okay, and then 2aex minus 3, which is 2 minus 3, you get negative aex. Alright, equivalent to ex. So here you can deduct a, you know that is equivalent to negative 1. So the particular solution that we get is ax ex, right? So a is negative 1, right? Multiply with x ex, so it become negative x e to the power of x. Alright, so now the full solution, I put it here lah. The full solution is yc plus yp. This one. So yc is given as c1e2x just now. We already find it. c2ex plus yp. So yp is negative x ex. So this is your complete solution. Alright. Okay, now let me look into second example where the right hand side here, mixture of exponential and cosine. Okay, alright, so again same step as previous. First we need to solve what is yc here. So first we form a characteristic equation, so it becomes m power of 2 minus 4m plus 5 equivalent to 0. Alright, so from here I calculate b, this one first, b to the power of 2 minus 4ac, I will get negative 4 power of 2 minus 4 times 1 times 5. So here I will get 16 minus 20, negative 4. Correct? 16 minus, yeah, negative 4. So b power of 2 minus 4ac here is less than 0. So means that we have the conjugate roots here. So let's find what's the value of m1 and m2. I use this way. A negative b, which is negative 4, plus minus negative 4 square root b power of 2 minus 4ac divided by 2. 2 times a is 1. So here you will get 4 plus minus square root of 4 is 2i. Divide by 2. So given as 2 plus I plus minus I. Alright. So the solution one is the negative. Sorry, let me check once again. This one is positive. Sorry. Positive. So this one is positive lah. Positive. This one become negative. This one become negative. So M1 will be negative 2 plus I. M2 will be negative 2 minus I. Alright. Okay, so the solution of complementary solution is given by C1E negative 2 plus I x plus C2E negative 2 plus I x. Okay. Alright, so now we settle for the YC. So let's do for the YP. First of all, the right hand side here is a mixture of cosine and also exponential. So if you look at the table here, the previous table, it says that if it's the combination of a mixture of exponential and cosine, okay, so the option 1, the answer will be YP e to the power of where is it? M1, sorry. How to say this? E to the power of beta. I put beta here lah. X Q naught. Okay. Or for this case is, let's see when we solve this part first. So now the Rx, sorry, about this. So now Rx is equivalent to actually e to the power alpha x, p, and x. But for this type of equation, this is actually e to the power of negative 2x from the question here. And then the real part only of EIX. Or in other words, is the real part only for e to the power of the answer here. Negative 2 plus m, the m. 2 plus I x. So alpha here is equivalent to negative 2 plus I actually. And the n here is equivalent to 0. Alright. So possible particular solution here, YP here, is given by this format just now, right? A E negative 2 plus I X. Okay. This is actually this one lah tadi but I transfer it to here. Alright. So the solution is actually the real part of this only, the real part of YP. eh. Uh, YP actual later will be only the real part of YP. Alright. I add another slide to show the continuation of calculation. Okay, so the solution of particular solution is AE negative 2 plus I x. Okay, so this solution is actually the alpha here is actually negative 2 plus I, which is similar like M1. Okay, so the treatment, therefore, treatment is needed. Treatment is needed. So it become YP become we multiply with x here, so that it can be linearly independent with each other. X, okay. All right. So now after we know that, what we want to do now, we want to find the coefficient of A. What's the value of A? So how to do that? Let's take derivative, dy over dx. So you will get here negative 2 plus I ax e to the power of negative 2 plus I x, okay, plus ae e to the power of I x. Again, use the concept of uv prime to u and v. And then we take the second derivative. We get here, after you solve it, you will get this value. AE negative 2 plus I x. Okay. Okay, now we insert back in the equation d to the power of y x power of 2 plus 4 dy dx plus 5y equivalent to e negative 2x cos x. And then we compare left hand side and right hand side to find what's the value of A. Alright. So here you will get 3 minus 4i ax e negative 2 plus I x, okay, plus negative 4 plus 2i ae negative 2 plus I x, okay, plus 4 times negative 2 plus I a x e negative 2 plus I x, the top part here, plus a e negative 2 plus I x, and then I continue down here, 5, 5y, 5y is a e negative 2 plus I x, equivalent to a e negative 2 plus I x. Okay. Oh, sorry. Equivalent to this, I make it equivalent to this. So tak ada A lah ni. So this one is the solution is this one, So after you solve, you get 2ia e negative 2 plus ix equivalent to 2 negative ix. So this one can be solved here, and A here you will get is equivalent to negative 1, no, positive 2i, Alright. Alright. So, I add another slide, So the particular solution here is given by yp ax e negative 2 plus I x, okay, equivalent to A is just now is 1 over 2I x e negative 2 plus I x. Alright, so um, let's remove the y to 2, sorry, the I here. So equivalent to 1 over 2I, we can multiply with I over I, x e negative 2x. I separate this one, and then e ix. Alright, so here you will get negative I over 2 x e negative 2x. For this part, eix, I change it to cos x plus I sin x. Okay. Or I rewrite, I multiply in I inside, 1 over 2 negative x e negative 2x, I multiply in, I power of 2, meaning that it become I cos x minus sin x. Okay, so the solution is only the real part. So the real part is 1 negative 1 over 2 x e cos x I, and then plus 1 over 2 x e negative 2x sin x. So the real part is only this one. Okay, so the yp here will be 1 over x e negative 2x sin x. So the total y will be yc plus yp. Yc just now is c1e negative 2 plus I x plus c2e negative 2 plus I x plus half x e negative 2x sin x. Okay.